Swayam Prabha. Digital India. Educated India.
So, welcome to today's lecture. In today's lecture, we will talk about smart and connected products. This will be the first lecture of a series of lectures on smart and connected products. So, the learning outcomes at the end of today's lecture will be that you will be able to identify key IoT characteristics, architecture and protocols in designing smart and connected products. And in the subsequent lectures on smart and connected products, you will learn how to select sensors for use in the industrial Internet of Things, okay? And you will learn how to apply a set of design principles in developing smart products. Okay. So, let us start with discussing some of the characteristics of IoT and how IoT is enabling digital transformation. So, digital transformation that IoT is enabling is in a sequence of phases. So, first you have a create phase, okay, where you need to connect day to day objects with sensors, intelligent electronic devices, okay, and advanced meters. So, there you are creating the system, okay, and this is part of the physical to digital transformation. From the physical objects, you are going into a digital realm. Then comes the communicate phase. In the communicate phase, the data which the sensors, the intelligent electronic devices and the advanced meters are collecting, that needs to be communicated, and to do that you may use routers, you may use remote terminal units, hubs, switches, and you may use networks such as 4G, 5G, etc. Then we go into the digital to digital domain. There we are integrating the data and we are aggregating the data that is coming in from the sensors through the routers, etc. Okay. So, we are integrating, and to do that we use the cloud, we use servers, we use data protocols and standards. We will discuss these in more detail. Okay. And then once you have integrated the data that is coming in from the sensors, then you need to analyze it. So, the digital transformation journey, you then need to analyze the sensor data to be able to carry out the transformation. So, that requires high performance computing. Why high performance computing? That is because the data that is being generated is really immense, and you can use stream analytics, you can use other analytics tools and software. And then once you have analyzed it, you want to visualize the data, you want to plot some graphs, you want to see some meaning, you want to generate some meaning out of the data. So, that can be done using dashboards, using wearables, using mobility solutions, digital twins, etc. So, using wearable devices, you can see some graphs from the data that you have analyzed. Okay. From the data that is analyzed, you can create dashboards, you can also use mobility solutions and digital twins to visualize the data. Okay. Yes, digital twins is a key part of our course. There will be a complete lecture on digital twins. It is essentially the replica of any physical system which continuously updates itself as the system evolves, and it also contains all of the physics to be able to do carry out functionalities such as predictive maintenance. Okay. So, it is essentially a twin of the physical system. It is like my brother has twins. So, they are two, so they are sisters. So, they were born at the same time, they are almost identical. So, twin is just the replica of the physical system. Okay. So, it contains all of the attributes of the physical system, but in the digital domain. That is why it is called a digital twin. Okay. We will learn about digital twins in this course in great detail, but later on. So, those digital twins will enable you to visualize what is going on with your physical system after you have analyzed all of the data. Okay. So, after that you need to augment it. So, you have got your data which from which maybe you have created some graphs, some plots and some tables, and then you need to make greater sense of it. So, you can use AI tools or cognitive tools such as machine learning, deep learning. Okay. So, that is also part of the digital to digital transformation. Why digital to digital? Because you are taking in digital input and again you are creating some digital output using your AI tools. Okay. And then we go from the digital to the physical domain. Here you can use all of this intelligence to automate your systems. You can use robots, drones, unmanned vehicles. Okay. You can act. So, you can take decisions based on the artificial intelligence that is coming in. Okay. Do you need to buy a new machine tool? Do you need to fix some cracks in your building? Okay. So, you can actually do something based on the intelligence that you have gathered. And then you need to assess what is the effect of all of this digital transformation, and that is done using key performance indicators. So, these can be financial KPIs, it can be operational KPIs. Okay. So, that indicate the performance of your digital transformation journey. Here again you can use some spreadsheets and carry out some more analytics to carry out your assessment. Okay. So, everyone understands how the digital transformation journey takes place in different phases. It is not just overnight, you need to be able to do all of these to create your digital transformation. Again, while you are creating this digital transformation, a key aspect is cyber security. You want to make your IoT systems secure. You do not want it to be prone to attacks by hackers, people who do not have the right mindset and who might harm your business. And the other issue is that of data governance. So, there is a lot of data being collected. This data may relate to people, may relate to animals, they may be sensitive data, okay, which should not be revealed. People's date of births, addresses, passwords. So, there has to be an effective data governance. So, everyone understands how to create that digital transformation journey using IoT. So, IoT has some key characteristics which we must understand to be able to design our IoT systems, okay, our industry 4.0 systems. So, these characteristics are intelligence. So, there should be intelligence in the system. You must be able to create an ecosystem. It is all about connectivity. We will see what this means. It is about communication, it is about security, it is about sensing, and it is about the enormous scale. 7 key characteristics. Now, let us look at each one of these characteristics. So, the first characteristic of IoT is intelligence, and that is coming in through the integration of hardware, software, computational capability and algorithms. So, you are bringing in a bunch of hardware, you are using software such as, well, at the basic level such as Arduino, okay, but also lots of other different analytic tools, etc. You are bringing in computational capability, so using supercomputers, GPUs with high processing powers, etc. Okay. And then you are using algorithms at various stages to analyze the data, to be able to create intelligence using AI tools, etc. So, all of this is creating your intelligence in the IoT system. So, this is enabling users to respond in an intelligent way to situations. So, it is enabling people to take decisions to be able to carry out specific tasks. And in this system there is big data analytics. So, there is a lot of data being generated. So, you are creating intelligence also from the big data analytics. Okay, so, that is why IoT is characterized by a lot of intelligence. So, you are gathering all this intelligence about real world objects and using that to make your world smarter. So, we are building an ecosystem. So, ecosystem is the place of IoT where from a perspective of various technologies, goals, communities and the picture where IoT fits in. So, all of these are creating the ecosystem. The technologies which you are using, the goals, the communities that are involved in it, and where IoT fits in. So, that is creating your ecosystem. So, the IoT ecosystem is like a community which consists of data and monetary flows which are helping connect enterprises and vendors together. So, there is data flow in the IoT ecosystem, there is also money flow, okay, financial flows, and it is joining together companies, and it is also joining together the vendors who are helping out these companies which are creating these smart products. So, the components of the IoT ecosystem are the gateway which is used, okay, analytics, the connectivity devices, the devices which are using, the cloud, the user interface, your databases, automation, and so on and so forth. So, all of these are part of this IoT ecosystem. So, in the IoT ecosystem you have all these elements: gateway, analytics, connectivity devices, the cloud, the user interface, the databases, and the automation that you are enabling, and so on and so forth. So, it is characterized, the IoT system is characterized by connectivity, where objects are brought together, and this connectivity is creating a collective intelligence, okay, the intelligence that is being generated from this connection of all the physical devices, and this is enabling network accessibility and also compatibility between objects. So, different objects of different types are becoming compatible with each other thanks to IoT. Another key characteristic is that of communication. So, devices are getting connected so that they can communicate the data, and this data can be analyzed, okay, and the communication can be over different distances, short distances or long distances or very long distances. So, there are different types of networks that are being used to enable this communication. Wi-Fi is the first, but there are also low power wide area network technologies, then such as LoRa and NB-IoT. Okay. So, NB-IoT is narrowband IoT, and this is low range. So, LPWA is used a lot now. So, these are all technologies developed by different firms, okay, and they are being used in the IoT paradigm. So, there are different use cases for this for the low power wide area use cases. So, you may use them in the office or factory or warehouse context to carry out remote maintenance or control. You can carry out optimization of your operations, and you can manage your staff. You can also use this to carry out elderly care in the home and also in schools. So, for tracking children, for tracking elderly people, maybe your grandparents, okay, or your parents if they are old. So, tracking them uses this low power wide area networks. Okay. Also for smart meters, for electricity, gas and water, you can use these networks. Communication is the transfer of the data, okay. It is actually the transfer of that message that you are sending. Connectivity is the when that message has transferred and two things are getting connected. So, again you can use them in monitoring and managing natural disasters. So, especially in mountainous regions with rivers, so where there might be mudslides, you can issue flood warnings, tsunami warnings, earthquake warnings, etc. So, in the local area, using these low power networking technologies, you can do a lot using IoT. So, also useful in the public infrastructure. Okay. So, for street lighting, predictive maintenance within your factory, you can use these networks. Very useful for transportation as well, for cargo or pallet management, logistics management and air sites, optimization of these systems, smart parking. So, optimization of transportation networks within your factory. For instance, if you go to these big companies like Reliance, etc., they may have companies that they may have factory sites that are 2-3 kilometers wide, and for optimizing the logistics within their factory, they may be able to use these low power wide area networks. Yeah. and also useful in agriculture for monitoring the water quality, temperature of the water, humidity, trucking of livestock, etc. So, various application use cases. The next characteristic of IoT is that of security. So, IoT devices are quite susceptible to cyber attack. So, there is a necessary for high level of transparency and also managing the privacy at the same time. Okay, so, there is a trade off there. So, managing both transparency and privacy at the same time is required, and that requires you to enable security solutions. So, it is important to secure the end objects, the networks and the data which is being transferred over the network. So, the objects themselves need to be secured, because if they are hacked, they may create catastrophe. Because for instance, imagine a chemical plant where there are chemicals being processed, some outside hacker gets access to it, he might release the chemicals which may cause harm to people. So, those end objects, the manufacturing sites of those chemicals, so those need to be secured. The network itself needs to be secured, okay, and then the data that is going over the network, you do not want that to be given out to people who should not have the access to it. The next characteristic of IoT is sensing. So, of course, we have talked a lot about sensors. These sensors detect or measure. What do they measure? They measure the environmental changes, what is changing in the environment, the temperature, the humidity, motion of people, okay, distance from different objects, and that is generating data. The sensing technologies are providing true information regarding real physical quantities in your environment. Okay. The next characteristic is that of enormous scale. So, the Internet of Things is being used on a big scale. We know for sure that there were 5.5 billion new things at least connected in 2015. It grew up to 6.4 billion in 2016. 2020 the number was up to 20.8 billion, and now it is even higher. So, the number of devices that need to be managed and communicated will go up, and so their management has become critical because of this high usage. Okay, so, you need to manage all of this data coming from billions of devices. So, now let us look at one example. So, this is not the most sensitive sensor what I found, but it still does. So, this you see here, anyone recognizes this? Well, good attempt, is actually a motion detection sensor. Okay. So, it is a pyroelectric infrared sensor. So, if some human moves in front of the sensor, then it will be able to detect it. Okay. Right now, it is not connected, but you will see when it is connected, it will detect that motion, and this LED will glow. Okay. So, very simple circuit, you can see here only 5 connections. So, let us see it functioning, then we will understand what is going on with it. Oh, it is already detecting motion. So, this is the sensor, and that is the LED. Okay. So, let us see what we can get it to do. Okay. So, it is already running, this is the program for it, okay. And now the motion is absent. Everyone can see on the bottom serial monitor. Okay. So, now should detect the motion, yes. So, it is not very sensitive, and there is a delay that I have set in of 1000 milliseconds. This is, did this glow? Yeah. Okay. See, it is working. This time it did not work. So, it has some error. Oh, there we go. When the motion is very evident, then it does glow. Okay. So, that is your PIR motion sensor. Yeah. Now, let us look at how to get it to work. So, to get it to work, I am getting it to work on a ESP8266 board. So, this is different from the ESP32 board that you saw here. It has probably a fewer number of I can take this off now. Okay, so it has a fewer number of GPIO pins, general purpose input output pins, but it works pretty much on the same concept, and you can see here that is its wireless antenna. And all I need to do is to connect the circuit and write the code and also install this board. So, to install this board, what I had to do was so you go here and under preferences you need to place the board manager URL, okay, and for this the URL was this dl.spacif.com/dl/package underscore. Oh, this is for ESP32. Think this, and the front one is for ESP8266. Okay. So, you need to place these URLs for 8266 and 32 separated by a comma, okay. And then once you have done it, then you go here and go to boards manager, and you will see that it will show up. So, you see I have already installed it. So, ESP32 and ESP8266, and then you need to say install. If I remove this, you can see here install button, okay. So, you need to click on that install button for ESP32 and ESP8266, then it will install this board on my computer, okay. And for this sensor I did not have to install any libraries, but for some of the sensors you will need to go here and say manage libraries, and then you can, for instance, for the disk. So, you see for the display which I showed, the clock, you will have these libraries and then you need to install them, okay, all within the Arduino IDE. So, it is just couple of minutes work and you have got the boards and the libraries installed, and then you need this piece of code, okay. So, this piece of code is going to make it all work. So, we will see how it will work. We will discuss that now. So, to get the circuit to work, I had to connect the positive of the sensor to the center. The output here I had to connect it to D7 pin. This positive went to the 3 volt input, the negative went to the ground, okay, and your D6 went to the cathode, no, this is the anode of the LED, and the ground went to the cathode of the LED, the shorter one, shorter leg, okay. So, that set up my circuit, okay, that was quite easy. So, these are female to female wires that I used, okay. So, they just go and plug into the ports, and then of course, you need to recognize which one is the positive and the negative, and that you can get by looking at the picture here, and that will tell you, of course, the middle one is the output, and then you will see this little chip here is different from this chip. So, based on that you will be able to identify the plus and the minus, and then you need to set it up. So, in this case I did not use a resistor across the LED, but it is suggested that you use the resistor, otherwise the current through the LED will be quite high and it will have a shorter life if you do not use the resistor. And then you hook up your circuit, and that is it. Then you need to set your code up, verify it and run it. So, these sensors allow you to sense motion, generally used to detect whether a human has moved in or out of the range. As I said, they are small, they are inexpensive, they are low power, and they are easy to use and they do not wear out. Okay. So, products based on this, straightforward. Any ideas? Sorry?
That water comes from tap.
Okay. Yes, 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 very good. So, automatic sliders when you get into stores or water taps, or you can place one in your car and there will be a buzzer. Okay. So, if there is a thief who is trying to steal your car, you may be able to detect that, or your house even. Okay. So, we use two integer variables. Okay. One is to print the status to the LED. So, this is the pin where the LED is connected, this is the pin where the sensor output is there. Okay. And then you create a setup function and you set what is known as the baud rate, and for the PIR sensor it is attached to ESP8266, it is 9600. Okay. For this particular board, the 8266 board, 9600 is the baud rate, and then you set the sensor as input. Okay. So, this variable, this is where you are getting your input, whether there is motion or not, and then the LED is throwing out the output. If there is motion, then it is red and it glows, and if there is no motion, it does not glow. Okay. Then you have a function which runs in a loop. Okay. So, it is constantly going to check. So, it is going to read the sensor output. Okay. And it is going to take that as input, and then if this is high, then it is going to write high to this variable status. Okay. And then it is going to print out motion detected in the output monitor of your Arduino IDE. Okay. It is going to print out motion detected, and then it is going to wait for 1000 milliseconds. Okay. Otherwise, if it is low, then it is going to print out motion absent, and it is not going to print out this high status. Okay. If you do not print this out, then the LED will just grow for a millisecond, you will not be able to see it. Okay. It is long enough. So, 1000 milliseconds is a second. So, 1 second glows. Okay. So, you can see it and you can perceive it. Does this code make sense? So, this is a basic code, and then you can build on top of it and make it more complex. Okay. So, you can use this logic almost for any sensor.
What is the use of status high and low?
Okay. So, this is writing out high to this pin, okay, this output. So, it is glowing. Okay. So, it is writing out this high.
How are high and low defined?
So, high and low are defined within the data structure of the board. Yeah, make sense? Okay, and that is why we have installed the board. So, the board has already all of these variables defined within it. Okay, so, it is quite simple. Right. So, now we have talked about the characteristics of IoT. Now, we move on to the architecture. Okay. So, the architecture can be defined with a set of layers. So, the perception layer, the transport layer, the processing layer, and the application layer. So, to understand these layers, just try to think about what these words mean: perception, transport, processing, and application. Perception is how you perceive the world. So, to perceive the world, you may use a camera, you may use some sensors, you may use some robot or some meters. Okay. So, that is enabling you to perceive the world. Then that data which is coming in from these from the perception layer is getting transported, and to do that you may use a router, you may use a Wi-Fi network, you may use Bluetooth, you may use transmission towers, all sorts of devices are available. Then once you have transported it, it needs to be processed, the data needs to be processed. Okay. It is all streams of zeros and ones. So, you need to process it. So, for that you can use some web service, you can use a data center, you can use the cloud. Okay. All of these are used in the processing layer. And then you have your application layer, where this is actually making some sense for real life applications such as smart health, smart home, smart city, and smart grid. So, all of you are ready with your proposal, please send it by end of today. Okay. So, do not be nervous, whatever you have written up, it is just one page proposal. You can of course add a few more if you wanted to explain your ideas, but it is not a lot. Sit down and write down your proposal. It can be any of these applications or any application that you think is suitable for you, micro factory, whatever, miniature factory, whatever fancies your imagination. Whatever is your dream product which you want to build, this is your one opportunity. You are on a next gen product development course. So, make the most of it, and that product may change your life, or at least it will give you some learning which you can use for jobs and other purposes. Okay. So, please send in your proposals and I am keenly looking forward to them, and based on your proposals I will order some more components and that will help you create your dream product. Okay. So, now let us talk about the importance of networking technologies. So, networking technologies enable these IoT devices to communicate with other devices, applications and services running in the cloud. Okay. So, the technologies that are enabling the devices to be networked and to communicate with other devices, applications, services are these networking technologies. So, the internet relies on standardized protocols. So, you may have heard of IEEE protocols. So, there are standard protocols that the internet uses to ensure communication between heterogeneous devices is secure and reliable. So, these standard protocols specify rules and formats that devices use to establish and manage networks and transmit data across these networks. Okay. So, these protocols like the IEEE protocols, they give some rules. So, these rules are worldwide, globally applicable, and these according to these formats you can establish these and manage these networks and transmit the data. Okay. If there were no protocols, there was no rule, then everyone would be transmitting data their own way and you would not be able to make sense of the data. So, how are these networks built? Well, these networks are built as a stack of technologies. So, you stack them up, different technologies one after the other, and you create your network. So, technologies such as Bluetooth low energy, it is BLE, it is at the bottom of the stack. Others such as IPv6 technologies are further up the stack. Okay. So, there are ones at the bottom of the stack and the ones at top of the stack. So, IPv6 technologies are responsible for the logical device addressing and routing of your network traffic. So, technologies at the top of the stack are used by the applications that are running on top of these layers, such as message queuing technologies. Okay. So, at the top of the stack they are the applications that are using what is there from the bottom of the stack. Okay. So, if you are thinking, well, where are these technologies being used? They are used even in your laptops. So, if you go to your network and if you go to this and if you right click and if you see properties, so you can see all these technologies are being used. So, IPv4, okay, IPv6, etc. Okay. So, take the time out to explore these. We will talk about some of these briefly, as much as is within the scope of design, but beyond that do take your time out to explore these technologies. Okay. So, there are two important networking models. So, one is the OSI model and the other is the TCP IP model. The OSI model is the Open Systems Interconnection model. Okay. It is an ISO standard abstract model. It is a stack of 7 protocol layers. So, these are physical, data link, network, transport, then session, then presentation, then application. Okay. And for the TCP IP model, you have network access and physical, then you have the internet, then you have the transport and the application. So, it is a less number of layers compared to the OSI model. So, TCP stands for Transmission Control Protocol, or IP stands for Internet Protocol. So, TCP IP or the Internet Protocol suite underpins the Internet. So, it is used for the Internet just as I showed you by right clicking on my Wi-Fi connection, and it provides a simplified concrete implementation of the layers in the OSI model. So, it is a simplified version of the OSI model. Okay. So, now let us understand what are these layers. So, firstly the network access and physical layer. So, this TCP IP layer subsumes both OSI layers 1 and 2. So, this one is physical and data both combined in one. So, physical layer, the layer 1 of OSI, it governs how each device is physically connected to the network with hardware. For example, with an optic cable. Okay, so, this is the physical layer. So, what am I using? Am I using an optical cable? Am I using wires? Am I using radio? Okay. For Wi-Fi networks, there are all these protocols, IEEE 802.11 etc. Okay. So, that is the physical layer. Then there is a link layer. At the link layer, devices are identified by a MAC address. So, every electronic device which can connect has a MAC address. Your laptop has a MAC address, your smartphones, they have a MAC address, okay, and they will uniquely identify that device. So, at the link layer, devices are identified by MAC address, and protocols at this level are concerned with physical addressing, such as how switches deliver frames to devices on the network. So, at this level, at the link layer, it is about physical addressing. How can you give a physical address, MAC address to each device, and how the switches are delivering frames to devices on the network. So, how are the frames, frame by frame, how is their transmission on the network using switches. Okay. So, it is all about the physical units, okay, in this layer. Make sense? Network access and physical layer. Then you have the internet layer. So, this layer maps to the OSI layer 3, which is the network layer, and it relates to logical addressing. So, protocols at this layer or the internet layer, they define how routers deliver packets of data between source and destination hosts, which are identified by IP addresses. Okay. So, this is where IP addresses come into play. Everyone knows about IP addresses? Yeah. So, 4 numbers separated by 3 dots. Yeah. So, like 192.168.10.5. So, those are IP addresses. Okay. So, IPv6 is commonly used for IoT device addressing. So, for IoT we use version 6. Okay. And then we have the transport layer. The transport layer, it focuses on end-to-end communication, and it provides features such as reliability, congestion avoidance, and guaranteeing that packets will be delivered in the same order that they were sent. Okay. So, it is about end-to-end communication, it is about reducing congestion in the network, reliability of the network, okay, and guaranteeing that packets which are sent in a certain order, they are delivered in the same order. So, for this again we use different protocols. One of them is UDP, or user datagram protocol. User datagram protocol. So, it is used for IoT transport for performance reasons. Okay. So, again take your time out. So, for your additional reading for your portfolio, okay, you can go and explore all of these concepts. Go and see the Wikipedia page, then maybe do some literature search, and maybe see some presentations, and just try to understand how these came out, which year this came out, who was the inventor, which company started this. Okay. So, how is it actually implemented, okay? What is the implication of this protocol? Make some downloads, do some extra reading, and that will enhance your knowledge. And then you have the application layer. So, this is the layer 5, 6 and 7 from the Open Systems Interconnect model, and this covers your application level messaging. So, for instance, at the application level you may use HTTP, okay, and or HTTPS. So, it is an application layer protocol that is widely adopted across the internet. All the web addresses start with HTTP or HTTPS. Everyone knows what S stands for? Okay. So, everyone understands these layers. So, for these 4 layers, there are different protocols, IoT protocols that are used. Okay. So, today's lecture will not go into the details, but you can do some extra reading on it. So, at the network access and physical layer, you use protocols such as IEEE 802.15.4, then we use the Wi-Fi protocols such as 802.11 ABGN, then Ethernet, so 802.3, then GSM, CDMA for your mobile communications, also LTE for your mobile communications. So, these are the protocols at the network access and physical layer. And then at the internet layer you use IPv6 or you use 6 low WPAN, RPL. Transport layer, user datagram protocol and transmission control protocol. Application layer, HTTPS, XMPP, COAP, MQTT, AMQP, etc., etc. So, figure out what these mean. Okay? So, that is your homework. So, go and explore. So, some of the key networking considerations for IoT are range, bandwidth, how much power you are using, okay, intermittent connectivity. Okay. So, you do not want them to be always connected to a network and consuming a lot of power, interoperability, ability of different sensors to operate together or different devices to operate together, and security. Okay. So, when you are carrying out your networking using the protocols that we discussed previously, you also need to consider these features that you need to embed in your network. So, let us talk about each one of these features. So, firstly the range, and you can set up many different types of networks. So, for instance, within our campus we have what? Which network do we have? No, of these four, which one? We have the LAN, right. So, this is a local area network, but then there are also PANs. So, personal area network, which is very short range, distances can be measured in meters. So, for instance, your wearable fitness tracker devices that are communicating with an app on a cell phone or BLE, Bluetooth Low Energy. So, that is a personal area network. Then you have your local area network, which is short to medium range, where distances can be up to hundreds of meters, such as home automation or sensors that are installed within a factory production line. So, or your communication over Wi-Fi with a gateway device that is installed within the same building. So, it is short to medium range. So, bigger than your personal area network. Then you have your metropolitan area network, which is long range or citywide. Distances are up to few kilometers, such as smart parking sensors installed throughout the city, which may be connected in a mesh network topology. That is your metropolitan area network. Then you have your wide area network, which is long range. Distances are in kilometers, and it is such as use of agricultural sensors that are installed across a large farm, okay, or a ranch, which are used to monitor microclimate environmental conditions across the property. So, that is wide area network, because that is bigger than your metropolitan area network. So, PAN, LAN, MAN and WAN, everyone understands? Yeah. So, you need to think about the range, whether you need to set up a PAN or a LAN or a MAN or a WAN. Okay, when you are designing your system, your smart product, think about which one you will need. Then you need to think about bandwidth. So, bandwidth is the amount of data that can be transmitted per unit of time. Okay, so, whether it is 10 Mbps, 100 Mbps, 1 Gbps. Okay, so, how much data can you transmit per unit of time? It limits the rate at which data can be collected from IoT devices and transmitted upstream. So, bandwidth is affected by many factors. So, these include the volume of data each device gathers and transmits. So, how much data is your device gathering and transmitting? Okay. So, do you have one sensor connected to it, 2 sensors, 10 sensors, 100 sensors? Okay, depends on the scale of your device as well. The number of such devices, okay, 10, 100, thousands, 10,000s, millions. Okay. And then whether the data is being sent as a constant stream or in intermittent bursts, whether you are constantly sending out the data or every 5 seconds, 10 seconds and so on and so forth, and whether there are any peak periods which are notable. Maybe the factory runs 9 to 5, that may be a peak period. Okay. So, you need to consider all of these to decide how much bandwidth you need, okay, how fast you want to transmit. So, if you have millions of sensors and you are choosing a 10 Mbps network, maybe it is not suitable. Okay. So, you need to select your bandwidth depending on the volume of data, the number of devices, and whether the data is being sent constantly or intermittently. Then you need to think about power usage. So, you need to think about how much power is being consumed from the transmitting device. Okay. So, how much energy is being consumed and over what range. So, transmitting data over long ranges will require more power. So, what is the range? Meters, kilometers, okay, across the World Wide Web to another continent. Okay. So, think about the range. You must also consider the power source, whether it is a battery, solar cell or capacitor that is being used. and its total life cycle. So, how long will this battery last? Then you need to think about the life cycle. Okay. If it is long and enduring life cycle, it will provide greater reliability, and but it will also reduce the operating cost. So, you may take steps in designing your devices so that they achieve longer power supply life cycle. So, they are usable over long periods of time, and then you also need to think about the maintenance based on that. Okay. So, how often do you need to replace your battery or your solar cell or your capacitor, and so on and so forth. So, IoT devices are not always connected, which is why we talk about intermittent connectivity. So, you saw many examples of sensors already from the IoT break times we had. We do not always want them to be connected, and you saw the delay function that I used. Okay. So, you can use such delay functions. So, in some cases the devices are designed to connect only periodically, or sometimes an unreliable network can cause devices to drop off due to connectivity issues. Okay. So, you need to think about reliability of your network, and sometimes you may lose them due to connectivity issues. So, you may have quality of service issues, which may be due to interference or channel contention on a wireless network using a shared spectrum. So, maybe there are many devices on that wireless network, so that can cause quality of service issues. So, your designs should incorporate intermittent connectivity, and they should seek any available solutions to provide uninterrupted service should that become a critical factor for your IoT landscape design. Okay. So, think about whether you need continuous connectivity or you need intermittent connectivity, and based on that you can decide how you can ensure quality of service and how you can prevent connectivity issues. Okay.
Sir,
yes.
why intermittent connectivity can be used over continuous connectivity? What are the advantages?
Yes. So, intermittent connectivity may be required if, let us say, you have placed a sensor in the wild to, I am giving an example, but there are hundreds of examples. So, you have placed a camera in the wild that will capture when take a picture when the cheetah goes in front of it. Okay. And that picture it will transmit over the network. If it is on all the time, then you are wasting the battery power, and you have to go in again and again to replace your battery, right. So, if it only turns on when there is motion detected and then transmits the data, then you use that battery can last for a really long time, right. So, you must send out data only as often as you need it. Okay. So, or you may have a factory that is running 9 to 5. So, that also is another form of intermittent connectivity. Switches on at 9, switches off at 5, next day when workers are in, again it switches on. The rest of the time you do not need to use up your power supply. Make sense? And then 9 to 5, when the shop floor is continuously operating, you want to probably send out the data continuously. So, you may need both intermittent and continuous depending on your application. Okay. So, in designing a network, you need to also ensure interoperability. That means, devices must be able to work with other devices, they must be able to operate with each other, okay, together. So, devices must be able to work with the equipment in which they are installed, with the systems, and they must be able to incorporate the technology. So, all of these 4 elements: devices, equipment, systems and technology. You need to think about how all of these can integrate with your device. Okay. So, you need your products to be interoperable. So, with so many devices connecting to IoT, interoperability can be a challenge, because many different protocols may be in use. So, how do you integrate? So, think about that. So, adopting standard protocols has been the traditional approach for maintaining the interoperability on the internet. Okay. So, using some standard protocols as we saw earlier, so such as those IEEE protocols or so on and so forth. So, use these standard protocols to ensure your interoperability. So, these standards are agreed upon by industry participants. So, people from different industries, they gather together in conferences and workshops, and they agree on these standards, and that avoids multiple different designs and directions. Okay, so, everything gets standardized. So, you have more devices that are interoperable. So, with proper standards and participants who agree to them, incompatibility issues and interoperability issues are avoided. So, however, for the IoT standardization process sometimes struggle to keep up with innovation and change. So, they are written and released based on upcoming versions of standards. So, these do change, okay, and there is innovation, okay, to for instance consume low power, to ensure more intermittent connectivity and so on and so forth. So, these standards do change. So, think about the ecosystem around your technologies. So, when you are building your smart products, think about whether these are widely adopted, whether they are open versus proprietary, whether you are using open source technology or proprietary technology which belongs to a specific company like Siemens. Okay. So, how many implementations are available? Okay. So, 1, 2, 10, how many people are using them? Okay. So, whether millions of companies are using them. So, think about that. So, all of this goes into designing your industry 4.0 systems. Okay. So, think about all of these aspects. Okay. So, the last thing that we will talk about is security, and security is key. So, security involves selection of networking technologies that implement end-to-end security, including authentication, encryption and open port protection. So, 3 key aspects of security. One is authentication, okay, authenticate the devices, the users, encrypt your data, and third is provide protection from open ports. So, a security model is provided by IEEE 802.15.4. Again, as part of your extra reading, have a look at these protocols. Okay. So, you learned about a lot of protocols today. Go and have a look. There are Wikipedia pages on each one of them. Then you can explore the articles below them as well. So, IEEE 802.15.4 includes a security model. It provides security features that include access control. Okay. So, how to control the access of different users, integrity of messages. Okay. So, messages are what they are in the right order, okay. Confidentiality of the messages and replay protection. So, these are implemented by technologies which such as Zigbee. Okay. Look up what Zigbee stands for. Okay. So, Zigbee is, for instance, if you use a robot, usually these Zigbee cards that you can use. Okay. So, for communicating using your joysticks. So, if you are controlling the robot, you will probably have a Raspberry Pi, and then you will have a controller board, and then you will be using a Zigbee controller which is then attached to these boards, and they are communicating with your joystick, okay, and then you are moving the robot around. So, look up this as well. Okay. So, we will talk about these 3 aspects of security. Authentication. So, authentication is about adopting secure protocols to support authentication for devices, for gateways, for user services and applications. Okay. So, you want to authenticate your devices, your gateways, the users who are on it, the services and the applications. Does this make sense to everyone? Yeah. So, you want to be using a protocol which is providing authentication. So, think about your multi-factor authentication that you use for accessing your email. So, you want to authenticate your devices, your gateways, your users, services and applications. So, a typical standard that is used for device authentication is X509. Okay. Consider using this. For encryption, if you are using Wi-Fi, you can use WPA2 for your network encryption, wireless protected access 2. So, if you look up if you go on your laptop and look up your properties of your wireless network, you will see your WPA2, your network ID and your SSID and your password. Okay. So, you can also adopt a private pre-shared key approach to create a safe and secure network. So, a key that is shared between maybe two users. To ensure your privacy and data integrity, you can use transport layer security or datagram transport layer security, TLS or DTLS. Okay. So, these are based on, so DTLS is based on TLS, but it is adapted for running over user datagram protocol. Okay. So, think about how you will encrypt the data, so that there is no unauthorized access. Okay. So, TLS encrypts application data and ensures your integrity. So, whatever application data is being transmitted, it is encrypted using transport layer security. Again, it is not the purpose of this course to teach you these protocols, because this is a design course. Okay. You can learn this if you go to the computer science department, but it is useful for you to know that these protocols exist. So, when you are designing your system, you need to take care and think about these aspects. And then you need to ensure your port protection. So, port protection ensures that only the ports which are required for communication with the gateway or upstream applications or services, they remain open to external connections. So, there are so many different ports on your computer. Okay. You do not want to be opening up all of the ports. So, you need to provide port protection. Only the ports that are required for the communication, only those you need to keep open. So, all other ports should be disabled or protected by firewalls. So, device ports may be exposed when exploiting universal plug and play vulnerabilities. Okay. Some when you are using plug and play. So, for instance, I am placing a little USB thing in my laptop to be able to use this. Okay. So, it is plug and play. Okay. So, I do not have to go and install specifically some software. So, when you use such universal plug and play devices, so it is communicating over some port on my laptop, right. So, that port was open, that is why it could communicate. Okay. So, these ports are often used to get into your system. So, you need to make sure that these ports should be disabled, or there should be a firewall on your system. So, universal plug and play should be disabled on your router. Okay. So, let us summarize what we learned today. So, the key characteristics of the Internet of Things are intelligence, ecosystem, connectivity, communication, security, sensing and large scale. So, IoT architecture can be laid out as layers. These are perception, transport, processing and application. So, there are two key networking models that we learned today: open systems interconnect and transport control protocol or internet protocol, TCP/IP. Then there are some key design considerations for networking. These are range, bandwidth, power usage, intermittent connectivity, interoperability and security. Okay. So, this was a very important lecture, okay, in the sense that if you go to an interview and they say, oh, you have learned design for industry 4.0 and IoT. So, these are the sorts of things they will expect you to be able to talk about. So, in an interview you should be able to talk about all of these protocols, these networking technologies, models, OSI model, okay, the TCP/IP layers. Okay. So, then you will be able to do well in your interviews. Also, you need to understand what these are and think about how you will build them into your into the design of your systems. Any questions at this stage? No? Okay. So, yeah, some of these articles you can find on the internet, connecting all the things in the Internet of Things. Do have a look if you can. This is a book which is okay. It has a lot of practical examples. IoT with Raspberry Pi and Arduino. It is actually a compilation. It is an Indian public. These are some lecturers from different universities in India. They have written a book. It is very expensive also. Got it in my office. You can come and read sometime. It has a lot of practical examples. Okay. So, it will just open up your mind to practical projects that you can do using IoT. It is basically a collection of different things from different sources, but still it gives you, but you will get lots of books like this. If you go to your bookshops, you will find a lot of practical IoT books. So, if you can get your hands on some of these, so that will accelerate your practical project as well, because there will be step by step instructions how to build your IoT devices or products. but then you want to innovate, you want to create your own thing. So, use that, use those experiments to create your own thing. Okay. And then there is this article IoT architecture layers explained by Adam Simmons. So, have a look, but then go in, do your own reading on what we have learned today. Okay. So, I think that brings us to the end of this lecture. Thank you everyone for coming to today's class. See you all in the next lecture.